Good morning everyone. In this class we'll discuss about balancing of redox reactions by oxidation number method. Oxidation number method is very simple. In this method we have to balance the change in the oxidation states. Okay. See some simple examples you may easily notice. Here MnO4 minus is called permanganate plus Cl minus, this has to MnO4 minus 2, this is manganate and this is Cl2. In this reaction if you see, the oxidation state of manganese is plus 7. In this case the oxidation state of manganese is plus 6. So what is the change in the oxidation state? Minus 1. Good. Here chloride is changed to chlorine. The oxidation state is from minus 1 to 0. If you notice this change, the rest things will be easy. For your easiness, I am saying to write these equations separately. MnO4 minus gives rise to MnO4 minus 2. Then Cl minus gives rise to Cl2. Here you write down the answer. That's all. Very simple. Here the oxidation state is plus 7. Just for a change, I am writing with another color. It is plus 7, this is plus 6. So change in oxidation state is minus 1. In this case, the oxidation state is minus 1, here it is 0. But you can see here, one chlorine is present left hand side, but here two chlorines are there. So just check whether they are balanced or not, which are undergoing the change. In this case, chlorine is undergoing the change. So here one chlorine is there, these two chlorines are there. So first you balance these chlorines. So 2Cl minus gives rise to Cl2. Each chlorine from minus 1 state to 0 it is coming. So minus 1 to 0 is, you can say the change is plus 1. Like the two chlorines are there. So total change is going to be plus 2. Our simple sense I will say. Here what is the total charge? 2 minus 1. Here what is the total charge? 0. So minus 2, you write something here which makes it 0. So minus 2 plus 2 is equal to 0. So you have to write something here which makes the equation easy. Minus 2 plus 2 is equal to 0. Here you can see plus 7 minus 1 is equal to plus 6. So whatever the oxidation state is there at left hand side plus whatever you are writing on the arrow must be equal to, when you are adding both of them, that must be equal to the product oxidation state. You can see now in this case the oxidation state has come. Here minus 1, here plus 2. So this change must be same. In this case, you have to make this as 2. For that purpose, just multiply this equation by 2. There is no need to do anything with this. Or in other words, if you want, you just multiply this with 1. Okay. So now you write down 2MnO4 minus plus 2Cl minus gives rise to 2MnO4 minus 2 plus Cl. Okay, now you can check this is the balanced equation. 2 manganese, 2 manganese, 2 4s are 8 oxygens, 2 4s are 8 oxygens, 2 chlorines and 2 chlorines. Charges also you can see, I am just giving you with another color. Here the charge is minus 2, here the charge is minus 2. So total charge this side is minus 4 and here the charge is 2 to the minus 4. Charge is balanced and everything is balanced. So this type of method is called oxidation number method. Very simple and very important. In a short way, you can easily solve. I'll give you one more example. See here. Very simple example. MnO4 minus plus SO3 minus 2 gives rise to Mn plus 2 plus SO4 minus 2. Okay, here very simple sense. First you write two equations separately. MnO4 minus gives rise to Mn plus 2. Second equation, SO3 minus 2 gives rise to SO4 minus 2. And write this the answer. Just check What is the oxidation state here? The oxidation state here is +7. Here it is given +2. You can check here. So the change in the oxidation state you can write that is as -5. +7 -5 is equal to +2. Right? In sulfite ion, the oxidation state of sulfur will be +4. That you know how to calculate. SO4 -2 is called sulfate, where sulfur oxidation state is +6. So tell me, what is the change in oxidation state? +4, +6, so you have to write here +2. Okay. So in the first equation, the change is -5. In the second equation, the change is +2. These changes must be same. So in order to make these changes same, just multiply the first equation with 2 and second equation with 5. And write here just by adding them. 2 MnO4 minus, sorry, this is minus only. Yes, this SO3 -2 must be multiplied by 5. So 5 SO3 -2 gives rise to 2 Mn plus 2 plus 5 SO4 -2. Okay, 2 MnO4 minus plus 5 SO3 -2 gives rise to 2 Mn plus 2 plus 5 SO4 -2. In this case, you can see better. These are already balanced. There is no need to change any of this. Very important point you have to remember. We are not going to change these under any conditions. 2, 5, 2, 5. These numbers should not be changed. Just check whether the oxygens are balanced or not and hydrogens. If oxygens are short, you add their water. If hydrogens are short, you add their H+. If the reaction is in acidic medium. Okay. It is very similar to ionic electron method. Just check how many oxygens are this side. For example, this side you see there are 8 oxygens. 2 4s are 8 plus 5 3s are 15 here. So total number of oxygens are here 8 and 15. That is 23 oxygens are this side. And this side you can check. This is 5 4s are 20 oxygens are here. This side 23 and this side 20 means what we have to do is you need just addition of this. This side you add 3 water. It's very simple. 23, 20. So we are making this as 3 water molecules. Now just check how many hydrogens are there. This is no hydrogens. This is also no hydrogens. So recently we have added 3 water molecules. Because of this you are getting there 6 hydrogens. So that 6 hydrogens are to be added this side. Plus 6H plus. That's how you can check whether this reaction is balanced or not. It's very clearly balanced. I will show you just by checking with the charges. 2 MnO4 minus, the total charge is -2. 5 SO3 -2, the total charge is -10. 5 to the -10 beta. And this is 6H plus, so plus 6. -2, -10, -12 plus 6. So the overall charge is -6. This is product side. This is just for class check. And product side you can see 2 Mn plus 2 means that is +4. And 5 to the again -10. Water is neutral, no charge. So +4 -10 means it is again -6. So reactants -6, products -6. So overall it is balanced. So in this way you are going to solve this. It's very simple method and easy one also. I will give you one more. One more equation I am giving you. Cr2O7 -2 plus NO2 minus gives rise to Cr plus 3 plus NO3 minus. Simply write down Cr2O7 -2 gives rise to Cr plus 3. NO2 minus gives rise to NO3 minus. Okay. Now just check what is the oxidation state here. chromium oxidation state is plus 6, here it is plus 3. Like the 2 chromiums are here only 1 chromium is there, just to balance this. 2 chromiums plus 6, here this side 2 chromiums plus 3. So overall oxidation state this side is plus 12, you can check. 2 6 up plus 12, this is plus 6, each chromium plus 3, 2 chromiums are there. The overall is plus 6. Plus 12 to plus 6 means the change in the oxidation state is minus 6. Plus 12 minus 6 is equal to plus 6. 2 chromiums each plus 6, 2 chromiums each plus 3. So change is minus 6. Each chromium is losing 3 electrons like that. Now look at this NO2 minus. NO2 minus is called nitrate, you know very well. Nitrate is with plus 3 oxidation state of nitrogen. Nitrate is with plus 5 oxidation state of nitrogen. So the change in the oxidation state is plus 3 to plus 5 is 2. There is no need to add anything because one nitrogen is already balanced. In the previous case it was 2 chromiums and it was 1 chromium, so we made it 2 chromiums. But there is no need now. Now you can see these changes. In the first the change is 6, in the second the change is 2. So in order to make these balance, just multiply with suitable factors. Here just multiply the second equation with 3, that's enough. 3 to the plus 6. Multiply and write down. So Cr2O7 will be as it is, Cr2O7 minus 2 plus 3 NO2 minus gives rise to 2 Cr plus 3 NO3 minus. Check this. Now what you have to do is just balancing of oxygens and hydrogens. How many oxygens are this side? 7 here. 3 to the 6, 6 plus 7, 13. So this side 13 oxygens are here. You can say 13 oxygen this side. And this side 3 to the 9 oxygens are there. So what we have to do? 9 and 13. So this side you need 4 oxygens. So add here 4 water. So the extra we are adding 4 water. This part you can't balance by this method. You can balance this by just using your common sense and old technique. 4H2 you are adding here. Next point is to add hydrogens. Hydrogens you can check here. This side no hydrogens are there. This side 8 hydrogens you can see here. 4 to the 8 hydrogens. So simply add here 8H plus. So left hand side you are adding 8H plus. Cr2O7 minus 2 plus 3 NO2 minus plus 8H plus gives rise to 2 Cr plus 3 NO3 minus plus 4H2. Got it? Now just to check whether these are correct or not, go with the final checking of charges. Cr2O7 minus 2, the charge is minus 2. 3 NO2 minus, the charge is minus 3. 8H plus, the charge is plus 8. Overall, it is equal to plus 3. This side you can see 2 Cr plus 3, the charge is plus 6. 3 NO3 minus, the charge is minus 3. So when you add these two, that will be plus 3. You can see left hand side the total charge is plus 3. Right hand side the total charge is plus 3. That means it is balanced. So your final equation is Cr2O7 minus 2 plus 3 NO2 minus plus 8H plus gives rise to 2 Cr plus 3 NO3 minus plus 4H2. So this H2O molecules and H plus you are adding just according to your idea of ion electron method. But the basic reaction you can balance very easily. That's why this is one fantastic method. So try some more. You will get all this. If you have any doubts, we'll discuss in next class. Till that time, have a nice day.